Good afternoon, good evening, everyone, and welcome to this public forum. My name is Carl Magnus Larsson. I'm the Chief Executive Officer of the Australian Radiation Protection and Nuclear Safety Agency, and we have organized this public forum in order to enable a little bit of a discussion on an application for a license that had been submitted by ANSTO. And I have a small and short presentation just to start with, and I'm sure that is coming up very soon. There is a little bit of delay, and now we go. So once again, welcome to this public forum, and we can go to the next slide. Before we move on in the proceedings here, I would like to respectfully acknowledge the traditional owners and custodians of country throughout Australia and their continuing connection to land, waters and community. We pay our respect to them and their cultures and to their elders past and present. So why are we holding this forum? Why today's forum? So I have invited submissions according to the legislation, and I have invited submissions from persons or organisations on the application by the Australian Nuclear Science and Technology Organisation for a specific facility. And in this case, it's a nuclear installation, which is the ANSTO Intermediate Level Waste Capacity Increase, or ILWCI, which is going to be located according to ANSTO's plan at ANSTO's Lucas Heights facilities in New South Wales. Since this is a nuclear facility, ARPANSA, according to the legislation, must invite submissions, as I said, from persons and from organizations. And this forum is part of this consultation process, which started already on the 1st of September, and that will end on the 15th of November at 5 p.m. And I will come back a little bit later to how you can submit or make submissions. But going forward a little bit here, so who will you hear from today? Well, you are hearing right now from myself. And when I have provided you with my introduction here, we will move over to Sean Jenkinson, who is the CEO of ANSTO, and who is going to give an introduction from ANSTO, and we will then hear more about the facility from Paula Berghofer from ANSTO, who is the General Management Radioactive Waste Management Services. We then move across to ARPANSA, and Jim Scott, the Chief Regulatory Officer of ARPANSA, is going to make a presentation on the process for regulatory assessment. And when we are through with that, we will go to a Q&A session. And Jennifer Stife at ARPANSA is going to facilitate that Q&A session, and she will divert questions to members of the panel. And there will be a number of people sitting in the background, the speakers, but also other people. And from ARPANSA's perspective, I would like to introduce Shamir Sarkar, who is going to be taking questions as well as we get them. And Sean is going to introduce the people on the ANSTO side who are going to be available to you as well. So if we go to the next slide, which is how can I ask questions? Well, there is a question mark, a double bubble on the top bar of the screen to the right, and if you press that, you will be able to enter into a column to the right of the screen where you can type your questions. And the questions will then be either dealt with by people who are sitting in the background here, and they will be responded to, or they will be posted to members of the panel. So you can submit those questions anytime, like now, and you can submit them after you have listened to the presentations or during the presentations. And when we come to the end, we will have a facilitated discussion or a facilitated question and answer session. If you want to make a submission, there is information on ARPANSA's website, and you can make a submission in different forms. You can send an email. You've got the email address there. You can go to the Have Your Say page on ARPANSA's website, or you can also send them by post, regular post. You have the address here. And as I said before, the deadline for making submissions is the 15th of November this year. And we will then, in the statement of reason, the CEO statement of reason, which will be the explanation to the decision, which is going to be taken at one point in time. The statement of reason will also outline how the submissions have been considered in making that decision. So I think that is actually everything for me. Thank you very much, and once again, welcome to this forum. I hope we will have an interesting hour. We would probably aim to be finished by about 7, but we will see how it goes. And with that, I would like to hand over to Sean Jenkinson, the CEO of ANSTO, to make some introductions from ANSTO. Thank you.
Thank you, Carl Magnus, and thank you to everyone for joining us on the call this evening. I would like to start by also acknowledging the traditional owners on the land from where we're all joining tonight, and of course recognising that we're probably joining from many different areas across the country. I'm joining from Gadigal country, which is part of the Eora Nation, and the land on which we operate our Lucas Heights facility was and always will be Darawal land. And I would like to pay my respects to their elders past and present and emerging, and also acknowledge any Aboriginal people joining us tonight. As Carl Magnus said, my name is Sean Jenkinson and I'm the CEO of ANSTO, and I'm joined by 2 colleagues on the call tonight. Paula Berghofer, who is the General Manager for our Waste Services, and will be giving a short presentation after this, and also joined by Hefn Griffiths, who's ANSTO's Chief Nuclear Officer. Both Paula and Hef have a deep knowledge and experience of safe management of waste, and after the presentation they will be available, as will I, to answer questions. Before I hand over to Paula, I would like to make some opening remarks about ANSTO, our role, and also some context for this public consultation and forum tonight. So ANSTO has been part of the Southern Shire community for well over 60 years, and we are proud to be a major employer in the area, and we're proud of the support we put into this community. ANSTO is central to Australia's research capabilities, and we have significant research infrastructure located on our Lucas Heights campus, as well as our campus in Victoria. We also operate nuclear businesses and businesses that are in the national interest, including advanced manufacturing and distribution of a range of nuclear medicines that are supporting Australians every week, enabling accurate diagnosis and treatment of diseases including both cancer and heart disease. We are a global leader in offering advice and support to the minerals and mining industry, and through the Opal multi-purpose reactor, we are able to irradiate silicon ingots, which are essential for reliable operations of high-powered, high-voltage infrastructure, such as power grids, and enabling new technologies to connect to power grids and other critical infrastructure. In recent years, we've opened a deep tech innovation centre called NANDI, which means look ahead in the Darawal language. We have a vibrant community of startups working from our new campus, and many of those are from the local community. I want to talk a little bit about sources of radioactive waste and the progress of the National Radioactive Waste Management Facility. About 80% of nuclear medicines used by Australians are produced at the ANSTO Lucas Heights facility. Nuclear medicine is the main source of ANSTO's radioactive waste. While we wait for the establishment and construction of the national facility, ANSTO safely manages and holds the active waste from the manufacture and production of nuclear medicines. We look forward to this waste and other waste held on our campus moving to a purpose-built national radioactive waste management facility when that facility becomes available. In recent months, there has been great progress towards the declaration of the site for Australia's first radioactive national waste management facility. ANSTO welcomes this progress. Over 60% of the community in Kimber, South Australia, have voted in favour of having the national facility within their community. It is now possible that Minister Pitt may formally declare the location for Australia's national radioactive waste management facility within the calendar year. Should the site in South Australia be declared, the land will be acquired by the Australian government and a series of technical and heritage works can be undertaken and regulatory applications made. Construction of the facility will commence following the Australian Radioactive Waste Agency, ARWA, obtaining the necessary approvals from the relevant regulators. So tonight, we're talking about the licence application for a facility at ANSTO. And we're participating in this community consultation as we're seeking that licence to build the facility that will enable us to hold the waste from our nuclear medicine production until we're able to deliver and transfer it to the National Waste Facility. We require this building as our current storage capacity for one form of waste related to the production of nuclear medicines is anticipated to reach capacity by 2027. The facility we're talking about is not a substitute for the National Radioactive Waste Management Facility. Technically, it's very different. This facility will safely hold the waste byproducts from nuclear medicine, but not in a long-term storage solution. The facility we are seeking is simply to enable ANSTO to safely hold more waste until such time as it can be prepared and sent to a national radioactive waste management facility. Now I'd like to hand over to Paula, who will take you through some of the technical aspects of the facility. Thanks, Paula.
Thank you, Sean. This evening, I will be giving an overview of the proposed new facility, including some technical specifications and how it will ensure that we will be able to continue to operate the Opal reactor, generate vital nuclear medicine, and maintain key nuclear research activities that benefit all of Australia. If we go to the next slide, radioactive waste is an unavoidable byproduct of operating a nuclear reactor and producing nuclear medicine. ANSTO produces molybdenum-99, which is distributed to hospitals across Australia and internationally every day. It decays into a nuclear medicine called technetium-99m, which is used to diagnose human cancer and a range of heart, lung, and musculoskeletal conditions. In the production of molybdenum-99, there are two levels of radioactive waste generated: low-level and intermediate-level radioactive waste. The easiest way to think about it is that you don't need additional shielding to come into contact with and handle low-level waste. Intermediate-level wastes, though, are more radioactive and they must be handled remotely. This is not to say that you can't work with these wastes. At ANSTO, we do just that every day. It's just that more shielding is required to keep workers remote from the waste and ensure that they are safe. For all work with radioactive waste, we monitor workers' exposure to make sure that it stays as low as reasonably achievable and, of course, well below all regulatory levels where human health would ever be threatened. On site, we use the terms contact handled and remote handled to describe our wastes instead of low and intermediate level, because it helps us describe those wastes which have not yet been characterised or classified yet. And that's why you might see in some of the documentation that we submitted for this licence application, those terms used. But for the purposes of tonight, I will use the term low level and intermediate level waste because that's the terminology we tend to be more used to. From all the activities at ANSTO, low-level waste accounts for most of the radioactive waste we generate. This is about 80%. These consist of things like contaminated lab plastics and glass, contaminated gloves from personal protection, cloths, tissues from research and medicine production, as well as materials from facilities management like used ventilation filters, pipework, or even items from instrument or facility decommissioning. Low-level waste we put into 200-litre steel drums. The red drum pictures I'm sure some of you are quite familiar with and have seen before, and we store these safely in racking in dedicated buildings on site. Some of the waste in the still drums contains shorter-lived radioactive isotopes. So after a period of storage and careful analysis and assessment, this can be discarded through normal rubbish streams. The remaining radioactive waste needs longer-term management. This waste will eventually be super compacted into less than half or maybe even a tenth of its size, depending on the material. Will then be put into an overpack, immobilised, and then that's ready to be transported to the National Radioactive Waste Management Facility once it's established. Intermediate level wastes account for the remaining around 20% of waste generated at ANSTO. It's these intermediate level wastes that are the subject of our submission to ARPANSA that we're discussing here today, as our storage capacity for these wastes are running out. I think it's important here to differentiate that the operational intermediate level wastes that we need our new proposed building for are different to the returned reprocessed spent fuel residues that ANSTO received back from France in 2015 and will receive in a second shipment from the UK next year. Those wastes have their own purpose-built facility at ANSTO, which does not have capacity issues and is not the subject of this request. This request tonight looks at the ongoing safe management of those operational intermediate level wastes that ANSTO produces on a day-to-day basis as part of our nuclear medicine and research. If we move to the next slide, so what are those wastes that we are talking about here? Well, fundamentally, there are three kinds of intermediate level wastes generated which need a storage solution. Two of these we're currently generating through our operations, and a third we will begin to generate towards the end of 2023. The first of these, and the primary driver for us requiring this new building, are called aluminium retrievable bins, or ARBs for short. These are rectangle bins with a standard volume of around 72 litres, and they hold different kinds of radioactive waste, but mostly that which is generated within a nuclear medicine hot cell as part of their production processes. These can be things like glassware, plastic tubing, cloths, or even separation columns. These are placed into the ARB and removed from the nuclear medicine production facility using a special shielded flask just for this purpose. And then it's taken to our current waste storage facility, which is nearing capacity. The second of these are called soft cups. These hold molybdenum-99 filtrate waste and are stacked and welded into a storage vessel, which contains layers of aluminium and stainless steel, and are placed into the existing waste facility using another different purpose-built transport flask. The third kind that you can see on the slide are called Synroc cans. We will begin to generate these from the end of 2023. Synroc is an Australian technology through which we at ANSTO will solidify our liquid wastes associated with nuclear medicine production into a rock-like substance. It means that it cannot possibly leak into the environment, and it is ready for long-term storage or disposal. The new facility to produce these cans, called our SIMO facility, will begin hot commissioning in 2023 and should be operating in 2025. For both the current intermediate level waste storage facility and the new facility, we will put 2 Synroc cans into each single ARB for their storage. So if we go on to the next slide, you can see a picture of our current intermediate level waste storage facility, which we've safely operated at ANSTO for more than 60 years now. This is a high security building, which is why we've provided a sketch rather than a photograph. We take security very seriously, but I can confirm that it consists of a series of pits underground and some above ground shielded storage locations. A few years ago, with the changes to the expected time horizon for the operation of the National Radioactive Waste Management Facility and analysis of our waste projections, we realised that we were going to have a waste capacity issue. Our current building would have no room for ARBs after 2027, which is before the national facility will be established. The issue with that is nuclear medicine production in Australia would stop if we couldn't store any more of these ARBs. It was at this time that we undertook a series of option studies and concept design activities, and after much discussion, the federal government allocated us $60 million at the start of this financial year to construct our new proposed facility, which is the subject of today's discussion. Given the time it takes to build a nuclear installation to the very high safety and construction standards, and with all the regulatory approvals required, starting this process to build it now is an appropriate time frame so that it can be operational before the end of 2027. This is based on our previous extensive experience in builds of this nature. Soft cup storage is less urgent for us, but we will run out of storage for these in around 2023 without a new building. They use different kinds of pits, and you will see this a little bit more clearly further on. From a functionality perspective, the building that we're proposing is a copy of our current one with some operational layout improvements. As we go on to the next slide, you can see where the existing building is and where the new building is planned to be located. We're fortunate that there's space on our site to co-locate these two buildings, as this will give us some good operational efficiencies. On this picture, you can see a number of shipping containers on the proposed site. These have since been moved, so this area is free now and ready for all of our building works to start once we get the approvals. Zooming in onto the next slide, you can see a top view drawing of the proposed building. The building itself will take up about 0.3 of a hectare. It's going to be around 50 metres long and 15 metres wide, around 10 metres tall and 10 metres deep. This will be fine-tuned during our detailed design process though. The building will be made of concrete and steel and will include below ground concrete storage vaults excavated into the rock. There'll be thick high density concrete on the floor as a shielding barrier to staff working in the building, and it will fit in with the surrounding buildings and road infrastructure currently in place, as you can see. If we move on to the next slide, through our concept design activities, we looked at what was the best layout and how we could optimise the footprint available for the building. Here you can also visualise why there are different storage capacities for both the ARBs and the SUF. They require two different kinds of pits to suit their different sizes and configurations. SUF storage is more like tubes with thick walls, while the ARBs are more like square pits. The design brief as we move into a detailed design phase is to provide at least an additional 10 years worth of storage for ARBs and SUF cups, and also to optimise and make the best use of the space that is available to us. And finally, on the next slide, we get to see a concept render of the outside of the proposed building. The building will have a filtered active ventilation system monitored to ensure there is no airborne emissions above levels set by the regulator. Local area radiation monitors will ensure that the facility is safe for workers. Moisture sensors in the pits will ensure no water egress, and fire protection to meet Australian standards and in consideration of our surrounding bushfire risk. While it is intended that all intermediate level waste will be transferred to the National Radioactive Waste Management Facility for long-term storage, this building itself will still be required for us to manage and safely store our operational day-to-day intermediate level waste from ANSTO nuclear medicine activities before it can be consolidated, packaged, transferred and taken to the national facility. Based on our current schedule, this $60 million project will be completed and operational in 2026. And if we receive ARPANSA's approval for a siting licence, we'll be seeking a construction licence in around 2022 and an operational licence in around 2025. During these phases over the next 5 years, dozens of local job opportunities will be created as we hire surveyors, architects, engineers, fire consultants, analysts, as well as a lot of tradies. This is an incredibly important project for ANSTO and our community, and will ensure the ongoing ability of ANSTO to provide the nuclear medicine and research outcomes that Australia needs. Thank you for your time today, and I'll now pass over to Jim Scott.
Okay, good evening, ladies and gentlemen. My name is Jim Scott and I'm the Chief Regulatory Officer at ARPANSA. So tonight I would like to give you a little overview of ARPANSA's role in this process, and also a little bit about the actual licensing process that ARPANSA has in place, and a little bit more details about the license assessment. So first of all, I'd like to talk about ARPANSA. We are an independent regulator. We're the Commonwealth Radiation and Nuclear Safety Regulator, and we independently regulate other Commonwealth bodies that use radiation or have nuclear facilities. Examples include ANSTO, Defence, CSIRO, Australian Federal Police. We've got about a list of about 40 government organisations that use radiation, 40 licence holders with about 100 licensees. And we use a risk-informed regulatory approach, which we hopefully is aligned with international best practice and ensures that licensees take responsibility for safety, which is a key principle, that the operator is prime responsibility for safety, and that we look to ensure that the people and the environment are protected from the harmful effects of radiation. So not only is ARPANSA a regulator, but we also are a health advisor, and in fact we belong to the Department of Health. That is our parent department, and we have other parts of ARPANSA which basically give advice to the government on issues of radiation and health. And for example, our medical radiation services branch looks at the diagnostic reference levels for CT scans and the doses delivered. We also have a monitoring emergency response section that looks at radioactivity in the environment, measurement of radioactivity in the environment, in soil and water, etc. So that's quite a broad range of activities that ARPANSA is involved in. And we hope to give high quality advice to the government. We are also a service provider, and basically we do various services, and I'll just give a few examples. We have the Australian Clinical Dosimetry Service, which does audits of radiotherapy linear accelerators to ensure that radiotherapy doses are accurate to patients, to ensure that health outcomes are optimised in radiotherapy. We also have the Personal Radiation Monitoring Service, which issues dosimeters for measuring radiation to industry throughout Australia, medical and industrial uses. So we also have other services such as the radio frequency calibration. So we offer quite a lot of services to the community that use radiation. But sort of the main part I'm here to talk about is licensing, of course, because that is actually where our involvement will be with the ILWCI. So we have received an application to site a new nuclear installation at the Lucas Heights site, and I'm going to give you a quick overview of the licensing process, hopefully to shed some light on what goes into that. We're independent in the sense that we're not connected to our license holders, that we can make an independent judgment of whether an application is fit for purpose. And we are subject to high quality, robust processes within our management system, which ensures that the outcomes are quality assured. So this slide coming up is a little bit of a schematic of the licensing process. So at the beginning of the licensing process, we receive an application which comes from the applicant, in this case ANSTO. They lodge an application. We screen the application to ensure that it contains all the components that it should. If you're interested, section 46 of our regulations tells you what we expect to receive from an applicant, and that would include, for example, radiation protection plan, waste management plan, emergency plan, security plan, etc. And so in the initial stages, we ensure that all of that is received. If it's not, we usually have to go back and ask for more information, which is that first look on the schematic, saying that we need to go back iteratively till we get all the information we need. When we've got it all, when we confirm that we've got all, we start the application review and assessment. So that is done by our technical assessors, who have experience in nuclear engineering, radioactive waste management and radiation protection, and of course they're regulatory officers first and foremost, so their familiarity with the legislation, the ARPANSA Act and regulations is critical. So we undertake a technical review of the application. Inevitably there are questions, and we have a question process that goes back and forth to ensure that we have all the adequate information to address the criteria that we need to be sure that the application is fit for purpose. Also, which is this part, the bottom rectangle in the middle here, the bottom green rectangle, is the public consultation. So our Act and our regulation, well, section 48 of the regulations requires ARPANSA every time it receives an application for a facility license to undertake certain actions, and if it's a nuclear installation, which this is considered to be, then we have to undertake a public consultation, invite the public to make submissions. So this is the reason why we're having this forum tonight, to allow the public to basically to ask questions, and basically to ask questions of both the operator and the regulator. There is also, as Carol Magnus pointed out earlier on, a process whereby you can submit written questions and written queries, and we encourage everyone that's got an interest in this to do this. All of this will be considered as part of the application process. So the final part, of course, is there is a determination and then a decision, which is either granted or denied, and the decision is announced. There is, of course, there is a process for appeal under Section 40 of our Act if the decision is questioned by the applicant. So that's just like, you know, there is ability to appeal to the minister on the decision. So one thing that I want to talk about is our staged licensing process, and this is basically international best practice for nuclear installations. And the stages that are important are siting, which is the stage that we are at with this particular process. The next stage is design and construction, which is actually the building of the facility. And then I would suggest probably the more important of the applications is the operation of the facility, to ensure that it can be safely operated for possibly decades. And then the final, which is the end of life of the facility, is the decommissioning closure. I will point out that an application is required for each and every one of these stages. So just because you have a sitings license does not guarantee that you will be able to operate this facility. So at each stage, the applicant has to submit a separate application. They have got different requirements, and again, you can check Section 46 of the regulations, which will tell you the things that we look for at each of these stages. And probably the most important document here is the safety case. It's not a single document, it's a collection of many documents, and that evolves as we go through the stages from siting, from construction to operation and closure, and it evolves as the design of the facility matures. It may be that the design changes through the process of the cycle, and that is why we have this stage process. And again, as I pointed out, this is international best practice. This is how it's done for many nuclear regulators globally. So, and it allows for continuous improvement, of course, throughout the life of the facility. It allows you to change the design, make tweaks if you find that some part of the design is not optimized, and that you can change that aspect, and that can be done throughout this stage licensing process. Okay, what are the inputs? So the most important input, I believe, is the ARPANSA assessors, the qualified ARPANSA assessors. We have people with, as I said previously, with experience in nuclear engineering, radioactive waste management, radiation protection, and these are the people who assess the license. We of course also have the public submissions, which we look forward to receiving to ensure that the public's concerns are voiced and addressed. We also have our Nuclear Safety Committee, which is able to give advice to the CEO of ARPANSA. It's established under the ARPANSA Act and meets regularly during the year, and these are the questions that can be put to the Nuclear Safety Committee, a very important group of experts external to ARPANSA, experts in their own right in nuclear safety, geotechnical science, etc., so in environmental science. And finally, we might seek external expert advice. Not necessarily, we can't always find the advice in our Nuclear Safety Committee, so we can and have done in the past gone outside of our Nuclear Safety Committee to seek independent advice, perhaps in reactor physics if it's the OPAL reactor, or it could be from external peer reviews, for example, through the Nuclear Energy Agency or the IEA. And we have undertaken an IRS mission recently in 2018, and we were planning to have another mission, but of course COVID has interrupted that return mission. So the licensing process. So that's just an overview, and the whole object is to determine whether the application demonstrates compliance with the Act, the regulations, codes and standards around radioactive waste management, radiation protection, and of course international best practice. Now, on international best practice, I would like to mention we are actively involved in radioactive waste management in a global sense, so that we are kept up to date with the latest thinking from the global community on radioactive waste management, and primarily through the Nuclear Energy Agency Radioactive Waste Management Committee, which I myself a member of the Regulators Forum, and of course the IEA Waste Standards Safety Committee, which are peak bodies in radioactive waste management globally. And what do we assess against? Now that's interesting, right? Of course, we have our own ARPANSA regulatory guides, and I would like to encourage the public members to go and have a look at our website. We have a whole lot of regulatory guides and codes and standards which are applicable, and I've just given you a selection here of a few which are key documents. Of course, the ARPANSA regulatory guide applying for a license for a radioactive waste storage or disposal facility. The next one here is the planned exposure code, or the PEC as we call it, which is RPSC1, which is radiation protection and planned exposure situations, and a key document ICRP 103, which is the recommendations of the ICRP, and they are currently being reviewed, and we're actually participating in the process of that review to ensure that the recommendations are made up to date. So, further information, I would also highly recommend that you visit our website and look at our review and assessment manual. This is actually the guide for the assessors, so it'll give an insight into what the assessors look for when they receive an application with regards to all aspects of the application. And if you just type in review and assessment manual in the search engine, you'll find it, and it's worth a look, having to see the issues that the assessors address during their assessment